Hi guys, in this video we'll look at recoil of a gun and application of conservation of linear momentum. So we look at a gun before firing and we see that the initial velocity of the gun before firing is 0 and the initial velocity of bullet is 0. So if we let mg to be the mass of the gun, and let mb to be mass of the bullet, we let ug to be the initial velocity of the gun, and ub to be the initial velocity of the bullet. Then we now have vg to be the final velocity of the gun, and vb to be the final velocity of the bullet. So what happens is that this is the gun and the bullets initially before firing. So initially before firing, the gun is having 0 velocity. So that's why the initial velocity is 0. Likewise the bullet. So the bullet is stationary. This is the initial velocity of bullet 0. On firing, you see that the velocity of the gun takes this direction, while this is the recoil velocity of the gun. You see that the velocity of gun tends to move opposite to that of the bullet, ejects backwards. So we want to see the conservation of linear momentum here. So we know that from Newton's second law of motion that F, force, equals rate of change of momentum, and if there is no external force in the system, if we take that the external force in the system is 0, we now see that this equation becomes dp equals 0. dp equals 0. So what does this thing imply? It implies that change in momentum equals 0. And if this is the case, it means that the final momentum minus the initial momentum equals 0. And the implication is that the final momentum equals the initial momentum, or the initial momentum equals the final momentum. So we look at this conservation of linear momentum for a recoil of a gun. So it has application in recoil of a gun. So we see that the momentum before collision will be equal to the momentum after the collision. Of course, we have introduced an introductory lecture on conservation of linear momentum and the concept of linear momentum. So you can go back to our playlist and search the video and watch. So if this is your first time of visiting our channel Naselefa, do well to give it a like, subscribe for more video updates like this. We upload videos on sciences and technology, and we have several videos already. So let us forge ahead. So you now see that from the conservation of linear momentum, you see that the velocity after this after we must have fired the bullet is different. So using this formula for conservation of momentum, MAUA plus MBUB equals MAVA plus MBVB. So this is the formula for conservation of linear momentum, where this is the mass of body A, initial velocity of body A. This is mass of body B, initial velocity of body B. This is mass of body A, final velocity of body A, mass of body B, final velocity of body B. In this case, we label this as mass of the gun, initial velocity of the gun, plus mass of the bullet, initial velocity of the bullet. This becomes mass of the gun, final velocity of the gun, plus mass of the bullet, then final velocity of the bullet. So you see that initially the initial velocity of the gun is 0. So it implies that the whole of this equation the whole of this becomes 0. The initial velocity of the bullet is 0. This becomes 0. So that we now have that 0 equals mg vg plus mb vb. So this can come over here so that we have minus mg vg equals mb vb. You see that this, we are having negative here. This shows that the velocity of the bullet is equal and opposite to that of the gun, and that is the recoil velocity. This is the recoil velocity. So this equation shows the conservation of linear momentum for recoil of a gun. So we shall be making use of this now to solve a simple problem. So as I've said, if this video interests you and you want to see more of it, you subscribe. The subscription button is below. You subscribe for more video updates. Share it with your friends or maybe who that it might be of interest to. So let us solve a simple problem. So the question says a man fires a bullet of mass 200 gram at a speed of 5 meters per second. The gun is of 1 kg mass. By what velocity does the gun rebound? So this is asking for the recoil velocity. So let's solve this solution. So we draw the gun. This is the gun. This is the gun. Of course, we know that the initial velocity of the gun and the bullet will be 0. So we'll be making use of the equation we have just derived. So this is the gun. As you fire the gun, this is the bullet. So the velocity of the bullet is in this direction, VB, and the gun rebounds. So this is the velocity of the gun. So using the formula for the conservation of linear momentum for recoil of a gun, you have that MB VB equals minus mg vg. So if we make vg subject of the formula, so we have something like this: minus vg equals mb vb upon mg. So and mb is given 200 gram, so we convert it to the SI unit. So this becomes 200 upon 1000. We have 0.2 kilogram. So kilogram is the SI unit of mass. So we have, this is 0.2 times VB is the initial the velocity, final velocity of the bullet, given as 5 meters per second. So again, it's in this SI unit, so we don't have need of conversion. So this is 5, and mg is the mass of the gun. The mass of the gun is of 1 kg, so no need of conversion here, so we have 1. So if you do this math, you have a Vg equals minus 1 meter per second. So we take the magnitude of this final velocity of the gun, we have 1 meter per second. So option A is the correct answer. You see that we're having minus here, showing that the velocity of the gun is opposite to that of the bullet. So this shows the direction, velocity being a vector. So the magnitude of this velocity, which is the recoil velocity of the gun, is given as 1 meter per second. So if this interests you, give it a like and subscribe for updates. Do have a wonderful day ahead.